Hello, good morning, good afternoon, good evening. My name is Daffa Fairuzaufa Raharjo with the NPM of 2006517915, and I'd like to present my final project for Embedded System 2. So, my title of the project is basically a robotic arm that can be controlled by these devices, or maybe this device, or maybe even a laptop or PC, because it runs by a HTTP web server, and we're gonna build the web. So, what is the problem? What is the background of me doing this? Aside from wanting some robotic arm from an Iron Man movie, but in a bootleg version of it, or like a dummy version of it, because the name of the robotic arm in Iron Man movie is dummy, but like this is the dummy version of the dummy. And I wanted to make some robotic arm so that I can, pick up something, or maybe I want to implement it for like a planter system, so it can pick the seed and put it on the pot. But then I thought, it would be more good. It would be more better if I can record the movement and then play it. So whenever I wanted to plant the seed without me reaching the seed, because human hand is not good when we touch the seed, because we have some salt and like acid. Our seed is very acid to, take the seed and maybe put the plant itself. Well, then there you go. That's the problem, and that's the objective. The objective is it can be controlled, it can be recorded, so it can record the movement, and then it can play the movement so that the robot is automatically remember the movement that I use. So, and then this is inspired by the robotic arm from Iron Man movies, but the dummy version of it. So I have three objectives. The first one is that it can record the movement. Secondly, it can play the movement, of course. And the third one is it can be controlled by these devices, maybe a tablet, phone, and laptop. And so moving on to the features, because we have the minimum of 3 features that need to be implemented. The first one is GPIO pin, because of course we needed that. If we don't use that, we don't have the capability to basically perform the servos and also another servos, because I only use servos and then some breadboard. Secondly, web servers. Web server is very have an important rules in this project, because it contains the HTML page, and basically it contains the controller of the web, and then automatically I can change the HTML code by OTA, which is over the air update, this is the third features, so that I can update the movement of the robotic arm, and also I can update the code from my laptop through the air from the local IP. And the last one, fourth one, is PWM, or pulse width modulation, which is I can control the servo to which degree I am interested in. And this is very important, because if I were not using the PWM, it just give me this movement. But then if I were to make it like I use the PWM, it can be like this, so I can control whether or not I want to like 20 degree or only 5 degree, or only 9 degree, or all the way to 90 degrees. Moving on to the assembly. So the first thing that I need is that the robotic kit itself, breadboard, some jumpers, wires, and also the servos and my laptop. So this is the video where I put and gather and assemble the robotic arm kit. So right now we are going to go to the code, and I'd like to explain all of the codes and basically what it does. So I have my laptop right here, and as you can see right here, this is the screen what I'm looking at. So the first thing, I will include all the libraries. I use I use the Wi-Fi.h, async TCP, ESP. I accidentally used Arduino.h. Let me delete that because we don't use that. We use ESP32 as our main microcontroller. And I use ESP async web server and ESP32 servo to control the servo, and basically the IO stream and SS stream because I will use the HTML and stuff. So async TCP and the ESP async web server is basically used for me to build the website and control the servo in there, to control the PWM. And basically this, coincidentally, I just thought like 2 days ago, this is the over-the-air update, because over-the-air update used the library of async TCP and also ESP async web server, and then I use this too, and I wonder why the features of OTA included, because basically it always it always updates over the air to move the servo and stuff using the web server. So maybe that's the OTA and stuff. So and I can change the code and upload it to the HTML and through the local IP for sure. So this is the servo pins. I declared the servo pins to the initial position. So I divided the servo to be 4 individual. The first one is the base, secondly the shoulder, and third one is the elbow, and the fourth one is the gripper. Basically the gripper is the grip, and the elbow is this side. I'll put the picture later, and the shoulder is from here. So this is the elbow, the shoulder, and the gripper, and the base. The base basically move like this, as you can see. And so this is the where I put my Wi-Fi. Sorry, not Wi-Fi, but actually the the Wi-Fi from the ASP. So the the ESP32 will emit the signals to basically we can connect to the Wi-Fi of the ESP32. So then we can connect to the the IP address, and basically we can control it from there. So moving on, async web server. So to put the async web server in the port of AT, and this is the WebSocket. So this is the interesting one. So I use the HTML to basically code the website. So this is some HTML going on, and let's go to the body. So you can see here. Wait. Okay, so this one is the request from the for the device to control the servo right here, and then this is when it got disconnected, when it's connected. So this is the record button. So when it goes to record, it will record the steps of the movement of the servo, and it will save it into the ESP32 and play it again when I press the play button. So okay, so this is the send current robot arm state, which is the state of it being the zero state, and this is the right servo values. This is the record steps where it records. So there's a delay there. I put a delay, and basically all of it. So I think I would like to search for servo. Sorry. Okay, wait. So okay, so each of the elbow, gripper, shoulder, I use it to key, because to move the servo I use that one. So in order for me to basically use the gauge widget in the HTML. So the lower, like the lower degree, the higher the degree. So that is the code. Okay, moving on into the discussion. The discussion will include the problems that I face when I develop this machine. So the first problem is basically it cannot power it on, because I think I mistakenly because there's so much ground pin, and I try to basically fuse it up, but then when I connect it to only one, it's so like five different ground pin to connect it to one ground pin. It doesn't go, like it doesn't power it up. So I use breadboard, and the solution was using breadboard and a DC adapter, and and there's the female jack, so I could put the ground in the VCC like this, like it kind of hold up, and it kind of grapple the male pin to go to the DC adapter. Second problem is stuttering. So this is the example. Yes, it is painful to watch. So when I see it, like there's no problem in the code, and and all of the jumper is already in place, and it's not loose end, like there's no loosened wires. So when I grab the robotic arm, I feel the all of the elbow and all of the joints is very, very loosened. So I try to screw it up again. I mean, in a good way. I try to tighten the screw using the screwdriver, and it works. So basically, because it loosened, when the servo started moving, it gotten loose, and basically there's some point where the mount of the servo is off, so I have to put it back, and I have to screw it over again. So that's the second problem and the last problem, and also the two solutions. The last one is the analysis and the conclusion. So the conclusion is these devices can help me to grab something not so heavy, but it's kind of pretty much useful for planting a seed. So I can basically implement this robotic arm to maybe a plant monitoring system, or maybe a plant monitoring system, or maybe a garbage system, so that he can pick up the trash and stuff. But if it's heavy, the thing is heavy, it cannot do it. So like it needs some smaller and lighter object to grab. And then I have accomplished to make a dummy version of the dummy robot in Iron Man to basically record the movement and play the movement. And third, I use 4 features, which is GPIO, OTA, web server, and also PWM. And then the last one, I faced the 2 problems, and I alhamdulillah solved the problem by 2 solutions. So my name is Daffa Fairuzaufa Raharjo. Thank you so much for watching. Goodbye.